All right, hello, hello, hello. Okay, this video is counting atoms. There are four aspects of this that we're going to talk about, and I'm going to continue the practice of stepping off screen so you can write stuff down. I would recommend, I've color-coded the stuff for this one, I would recommend you only copy down the red stuff until we finish, until I actually lecture over it, then copy down, pause it, copy down the blue stuff, pause it, move on to the next one. Yeah. I would also recommend that you need to know some of this stuff as terms. Like, I am not going to quiz you on the test or on a quiz about what is the term for a one or two letter representation of an element's name or one or two letter abbreviation for an element's name. But your final, your comprehensive final, that's going to have questions from all four of our units, that could vary. That's mostly going to be vocab. I'll tell you, it's just mostly going to be vocab because it's going to be multiple choice so that we can grade it pretty quick and get it in a grade book. So if you haven't been making or using those flashcards that we've been telling you to make throughout the year, you should probably do that because here's two for, good Lord, for element symbol, another two for subscript, things that you need to know. Okay, now, if you haven't paused it yet, you should pause it and write down the red stuff. Your heading for this, your topic is counting atoms, and the first thing we're going to talk about is element symbols, which should be mostly review. All right, I'm going to assume you've done that. So, element symbols in a chemical formula are the letters. So, in the formula, I'll go with the one we talked about in the last video. We had H, whoops, okay, hey, I need to turn the pen on before I start trying to write. In the formula H2O, there are two elements because there are two different capital letters. Now, we also have chemical formulae, like the more complicated one I had last time, which was this, I think, NH43PO4. Okay, in this, again, we have four capital letters, so this is going to be four different elements. Now, where things can get exciting, I'm going to pause this and write this one down. Okay, so here's another example, CaBr2. In this, there are four letters, but there's only two elements because, again, only the capital letters initiate or show the beginning of a new element. That lowercase letter is part of the symbol for this. Now, there is one thing I need to mention because it's going to come up. Because sometimes when you're looking at the fonts that we've typed stuff up in, it can be just a little hard to tell whether that is a lowercase I or, sorry, a capital I or a lowercase L. Okay, sometimes with certain fonts, you just can't tell. So I'm going to tell you two element symbols that you need to be aware of and keep your eye out for. That is this, which is aluminum. You will never, well, first off, there is no element symbol that is just a capital A. So if there's an A, that thing after it, that's an L. It's not an I. It's not A something iodine. Okay, this is aluminum. The other one you're going to see a lot is Cl. Now this one's a little harder because carbon is a thing. Okay, so whenever you see a C and then a line like this, you're never going to have carbon and then iodine. At least not in this class. Not in physical science. You're never going to have to deal with carbon and then iodine. Anytime you see these, that is chlorine. That is a capital C and a lowercase l. You have to keep these two in mind. Okay, you're going to see both of them on the practice worksheet that you're about to do. Okay, so make sure that you know these. Okay, because these are going to pop up a lot. Okay, so now I'm going to step off to the side and I'm going to let you write down the blue here, subscripts. All right, I'm going to assume you've done that. Okay, subscripts only apply to the element that comes immediately before it. Okay, so in this chemical formula, the 2 is the only subscript. Actually, that's not true. The 2 here that we can see applies just to the Br because Br comes before it. So this is saying there are 2 bromines. There is actually another subscript in this chemical formula. We just didn't write it down. It's the same subscript or the same number that pops up all the time that we just kind of ignore. And that is a 1. There is actually an implied 1 after calcium. Okay, but we don't write it because we wouldn't have written Ca if there wasn't 1. Okay, we only put subscripts that are 2 or higher. Okay, so I'm going to put a couple of examples up here. So I'm going to pause this while I do that, and then we'll go through each of those. All right, so I've got 4 examples here. We're going to start with NaC2H3O2. Okay, so there are subscripts in this. The subscripts only apply to the element that comes immediately before them. So here, there is a 1. So Na, there's only 1. There are 2 carbons, 3 hydrogens, 2 oxygens. In this one, there are 2 nitrogens, 4 oxygens. In this one, there's 1 of each. But what about in this one? Well, Na2SO4, there are 2 Nas. There's only 1 sulfur because this 4 only applies to the oxygen, just like this 2 only applies to the carbon. It doesn't apply to the sodium. So this doesn't apply to the sulfur. So 2 sodiums, so yeah, that's sulfur, yeah. 2 sodiums, 1 sulfur, 4 oxygens. Okay, so that's it for subscripts. Now I'm going to erase this and move so you can write down the stuff for parentheses. Hopefully you know what those are already. All right, so occasionally you are going to run into equations with parentheses. And they look big and confusing and complicated, but they really aren't. Okay, so we're going to start off, again, pause this, write this down. Okay, so we add parentheses when a subscript needs to apply to multiple elements. Now, this only matters with things called polyatomic ions. Okay, so I didn't turn my pen back on. So we only use these with polyatomic ions. Now, polyatomic ions is something we are not going to talk about in physical science. However, you are going to see parentheses in chemical equations. And sometimes you're going to go, well, why didn't they just get rid of the parentheses and move that 2 and just put that in instead? The reason is because of this. If you do that, then we can't tell what that polyatomic ion is. Okay. By the way, poly means many. Atom is atom. And then ion. So this is an ion that's made up of multiple atoms. Okay, again, we're not going to spend any time on polyatomic ions in this, but I wanted to mention them. I'm going to throw a couple equations up here that have, or a couple chemical formulas that actually have this, and then we'll talk about that. I missed. All right, so I've got 3 examples here. We're going to start with this one. So CaOH2. This 2 applies to both the oxygen and the hydrogen. Okay, and you are always going to multiply. So there is currently an understanding that there is a 1, a 1, and a 1. So then when we are counting here, we would say, oh, well, 1 times 2 means there's 2 oxygens. 1 times 2 again means there are also 2 hydrogens. However, you have to remember that the same rule applies that we talked about with subscripts a little bit ago, that subscripts only apply to what comes immediately before them. So for that, here, another old friend here, we have NH4, 3PO4. Let's start outside of the parentheses with this piece here. Okay, we already said that this 4 doesn't apply to the phosphorus. It only applies to the oxygen. So there is 1 phosphorus and there are 4 oxygens. Well, when we're looking at inside the parentheses here, this 4 doesn't apply to the hydrogen. Sorry, it doesn't apply to the nitrogen. It only applies to the nitrogen. This 4 only applies to the hydrogen. It does not apply to the nitrogen. There, I got it right that time. Because after the nitrogen, there is a 1. So when we multiply here, there would be 3 nitrogens and 12 hydrogens. And then down here, one last example. I want you to pause it, figure out what you think this is. Okay, I'm assuming you have done that. There are 2 aluminums, because subscript 2. 3 sulfurs, because you would take 1 times 3. And 12 oxygens, because you would take the 4 times the 3. And that's pretty much that. The last thing we need to talk about are coefficients. Okay, so coefficients is the orange/yellow here. So I'm going to just get out of the way, let you copy that down, pause this. Okay, cool. So coefficients will sometimes show up when we are looking at chemical equations. Now, for now, I'm going to throw them in there just to remind you, because you need to keep these in mind when we start balancing chemical reactions later, which we're going to be doing at the end of this unit. That's the last thing we'll be doing in this unit. So those numbers have terms. There's something that means that. They're called coefficients. So, for example, I shouldn't have erased all those. I should have left them. Here, can I hit undo? I can. All right. So if I put a coefficient out here of 3 or 2, or in front of this one let's go with a 6. Why not? Okay, so now these formulas all have a coefficient in them as well. So what you would want to do is figure out, you multiply the coefficients, just like you do subscripts with the parentheses. Now, what some people find easier, rather than trying to do it all at once, and this is perfectly fine, instead of doing it all at once, they'll list them in steps. So, for example, if we're going to do this one, if we're going to do, do I have room? Yeah, I'm going to scroll down where I have a blank page. Let's do that. All right. So here we've got some empty space to work with. You turn the pen back on. Okay, so we have I forgot the 3, 3CaOH2. So when we're counting here, what we're ultimately going to do is we're going to list the elements, Ca, O, and H. And I'm going to put a colon. Some people put a dash. It's really up to you, just so long as you have some kind of divider here. And we're going to figure out, first off, ignoring the coefficient. How many of each of these are there? Well, there is 1 Ca, 2 oxygens, and 2 hydrogens. And then we're going to multiply each of these by 3, because 3 is our coefficient. So 3 times 1 would be 3. 3 times 2 would be 6, which means this would also be 6. So let's do this one here next. So we have 6 Al2 SO4 3. Okay, so first thing we're going to do, we're going to list out the elements. So Al, S, and O. But this time I'm going to show you how to do it without doing this. And I will do this again on the last one. Okay, so for this, what we're going to do is we need to multiply everything that needs multiplied. So we're going to start with a subscript. That's the 2. There is no other subscript that applies to Al, because Al is not in parentheses, so 2. Then we're going to take that 2 times 6, so 12. Now for sulfur. Well, sulfur has a subscript of 1. It's not written, but there's a 1 here. That 1 is, or that S is inside of parentheses. So we need to take 1 times the number on the outside, which is 3. So 1 times 3 is 3. And then times that again by our coefficient. So that would be 3 times 6, which is 18. Are we starting to see how we can get some really big numbers here? Last one, we have 4 oxygens. We take 4 times 3, which is 12. And then 12 times 6, which is 72. Okay, so you can get some pretty big numbers. I will tell you, oxygen's the one that's always big. Oxygen's always enormous compared to everything else. Because oxygen's in everything, and there's usually 3 or 4 of them. So, just a heads up. Oxygen gets big. Now, for this last one, I'm going to go back and do this again to review this, because I think a lot of you are going to prefer this option. So, we have 2NH4, 3PO4. So we're going to list out our 4 elements, which are nitrogen, hydrogen, phosphorus, and oxygen. Can you see that? You can? Okay. And then I'm going to put a colon on each of those, which takes a lot less time on paper than it does with marker. Okay. So if we ignore this 2, then we have 1 times 3, which is 3. So there are 3 nitrogens. Then 4 times 3, 12 hydrogens. 1 phosphorus. Okay, I definitely picked that up. Let's try that again. 1. There. 1 phosphorus. And then oxygen, we have 4. Then we put our line, and we're going to multiply all of these times 2, because the coefficient is 2. So 2 times 3 gives us 6. 12 times 2 gives us 24. 1 times 2 is 2. And 4 times 2 is 8. So these would be the answers that you're after. Okay? Now you can get these in 1 step, like we did in the red one here, or you can do them in 2 steps, like we did in blue and green. I will take either of these. This column is the one that has to be correct if you're doing the 2-step process. Okay, but I am fine with you using any method. So I'm going to erase the board now, and I'm going to put another one of these up here. And I want you guys to work on that. You might have seen me scroll past it a couple of times, but that's the one we're going to do now. So I'm going to pause this, erase, and then pull that out. All right, so here is a chemical formula. I want you guys to count this, like we just did for those last 3. That's the assignment. That's what you have to be able to do in counting. First, list the elements, figure out how many there are of each. So pause this and do that. All right, now I'm going to go through it. So first off, the first thing we are going to do is we are going to ignore that 5. We're going to pretend that 5 doesn't exist. And we are going to list out our 3 elements, which are calcium, phosphorus, and oxygen. Pretend that looks like a capital O. Okay, and now we need to count. How many of these are there? How many of each are here? Well, calcium, there are 3. Phosphorus, there's 1 times 2, so 2. And for oxygen, there's 4 times 2. So 8. Okay? But we are not done because we ignored this coefficient. We now have to account for that. So we need to take each of these 3 numbers times 5. So 3 times 5 means 15. 2 times 5 would be 10. And 8 times 5 is going to be 40. So in this equation, in this formula, there are 15 calciums, 10 phosphorus, and 40 oxygen. This is what you are doing on worksheet 4.1a. Okay, it's just 18 formulae for you to practice counting on. Okay, that is a paper worksheet. On worksheet 4.1b, that is vocab practice. Okay, that's all those things that were listed out, those color-coded terms. There are, well, yeah, that is repeatable. You can retake that as many times as you want. Use that to study. Make sure you know what I'm talking about, because when I say coefficient, you need to know what that means. When I say subscript, you need to know what that means. Okay, there should be a key available for the paper worksheet available on Canvas, so you can check your answers as you go. That is it for this video. You can go back, rewatch parts of it if you need to, but I'm going to sign off for this. Have a wonderful whatever, and I will see y'all next time. I missed.